Hello students, this is part 2 for question 2 in your revision in your workbook. Okay, so this is part D. They ask you for part D to find the coordinates of B. B is basically here. It's a point on the BD line and it's also a point on the BC line, right? So if I solve these two equations, right, equation on the BD line and equation on the BC line, I solve it like simultaneous equation, I can get the coordinates of B because B is on the BD line and it's also on the BC line, right? It's a common point of BD and BC. So BD equation is already a previous answer. BC is also a previous answer. So you can solve, right, equation 1 and 2, right? Basically you substitute 1 into 2, right? So it becomes negative 5x plus this one. Okay, and then just need to rearrange and simplify. This one you throw here is negative. This one you throw here is negative. So denominator is 2, so times 2, 5 times 2, 10. This one denominator is 2 times 2, so this one is 26. Will give you negative 39 over 2. This one is negative 13 over 2. Okay, so if I bring, because I need to find x, if I bring the fraction over, it's going to flip. Negative is still negative, huh? Okay, remember negative is a negative number. The negative you need to copy back. Operation is multiply, so it's divide, so you just flip it. So negative negative is going to give me positive. We can simplify like this, right? 13 and 39 are multiplies. So this one divided by 13 is 1. This one will be 3. So x is basically equals to 3. So once you get your x, you can also get your y, where you can sub in either the BD equation or the BC equation, right? So let's say you sub in the first equation, x equals to 3, which will give you negative 15 plus this one, negative 2. Okay, so this one is negative 2. That means coordinate B is basically 3, negative 2, right? And then you can continue with D. D, where it sits on the BD line, so you can use BD line. You can solve AD line, and DC line is a bit difficult because we do not know, right? We do know BD. You can get, right, gradient of A is B, and then that is the gradient of DC. You can get equation of DC, right? Or you can also, since BC gradient is the same as AD, you can just use that gradient. So you don't have to calculate and just use A as the coordinate. So the gradient of BC is already found previously, right? BC is basically 3 over 2. This is a previous answer, please check, right? We already found gradient of BC, which means gradient of AD is also 3 over 2 because they are parallelogram. Opposite sides have the same gradient. Okay, and and we need one coordinate to find equation AD. So A is already given. A is a line on AD, so we can use A. Okay, so y equals to mx plus c. Sub in y coordinate, which is 5, gradient 3 over 2, x coordinate, which is -1. Get your c, -3 over 2, so c equals to 5 plus 3 over 2, c equals to, denominator is 2 times 2, so 10 times 2, 5 times 2, 10, which is basically c equals to 13 over 2. Rewrite the equation, y equals to 3 over 2x plus 13 over 2. So this is basically equation of AD, right? And you can solve the two equations AD and BD to get coordinates of D, because D is a common point on AD line and is also on the BD line. So if I solve AD and BD, I will get coordinates of D, right, where they cross or intersect. So BD would be -5x. So this is BD. So you solve these two equations just like previously, right? First equation equals second equation, so 3 over 2x plus 13 over 2 equals to -5x plus 13. So this one is plus 5x equals to 13 minus 13 over 2. Denominator is 2, so times 2, so this is 10. Denominator is 2, so this is times 2, 26. So this one you get 13 over 2x. This one you get 13 over 2. So if I bring over 13 over 2, you flip the fraction, right? You cut off. So basically it's just 1. So our coordinate D is 1, comma, okay, y coordinate I need to find, right, before I forget. Y coordinate, we need to sub in any of the equation. So can be BD. So y equals to -5, sub in -5 plus 13, which will give me basically 8. So coordinate D is 1, 8. This is the coordinate D. Okay, you can sub in any of the equation that you solve, any of the two equations.